So first, the idea for this video came from two Microsoft Learn tutorials. The first tutorial is where they were using Microsoft Semantic Link to clean data by looking at functional dependencies. And the second tutorial is where they were essentially extracting and calculating out Microsoft Power BI measures using Semantic Link. And I made a video on this earlier, which was kind of just my introduction to Python with Microsoft Fabric, which you can find on my channel if you're interested in. But when I was looking at this semantic model notebook, what they have here is they have a directed graph. So directed graphs are really good at modeling relationships, and they're often actually used in networks. When you're thinking about Power BI, when and especially measure relationships, you really can pretty easily visualize them with a directed graph, because what you have is you have kind of these nodes, right? And so a node would represent a measure, and then you have an edge which represents a relationship linking to another node here, another measure. So if we think about a measure as a node, a measure can have both upstream and downstream nodes from it. So hopefully you're starting to kind of see where I was going with this code and where my ideas were. The idea here is that we could feed a Microsoft Fabric notebook all of the measures and their definitions. And then we could essentially convert all of those measures into nodes and use the formulas to generate edges. And then we could essentially find a measure and we could find all of the upstream nodes and then all of the downstream nodes and then dynamically create a graph. But before we could do that, we need a complex Microsoft model. I went ahead and I downloaded the sales and returns v2019 sample, and then I published it up to my Fabric capacity. And this is a pretty complex model, actually, if you look at it. So we have a ton of different tables, and they're all interconnected. So probably not as messy as some of the ones you've maybe worked with at work, but still a big model. And then we have all kinds of DAX in here. And all this DAX is all interconnected. So let's jump in and let's kind of start coding, and let's see if we can figure this out. Okay, so here I am in a Microsoft Fabric notebook. And the first thing I'm going to try to do is I'm going to try to write some code to pull some measures. So I'm going to have to import the Senpai or the Semantic Link Fabric module so I can work with Microsoft Fabric data, Microsoft Power BI data. So I'm going to import that module. So I'm going to go import and then sempi.fabric as fabric. And I'll go right here and I'll just add a comment. It's always good practice to add comments. So I'll go importing the fabric module. Then I'm going to go ahead and I'm going to create a new cell. I'm going to define some variables. So my first variable I'm going to define is going to be my workspace name. So it's just going to be a string right now. So I'm going to go workspace, sneaker workspace, because that's a workspace I have in this Fabric tenant. I'm going to go data set. And this is going to be the data set that I want it to look at. I'm going to go sales and returns sample v2019 12. Then next things I'm going to do is I'm going to add some code, and I'm just going to make sure that I can return all of the measures in this notebook. So I'm going to go fabric.list measures. And then I'm going to go my workspace. It's going to be equal to my workspace variable. And then my data set is going to be equal to my data set string variable. Okay. And I'm going to go ahead and I'm going to run this. And we're just going to make sure that this is running correctly. So let's go ahead and let's give it a second to run. Okay, so my Spark session is starting. It can take a little while to have some startup time, but here we go. And any second now, we'll see this start to click and run through. Okay, so there we go. It ran, and then if we let it go right here, here is all of the measures in that model, and here's the formula. So let's go ahead and let's take a look at the data structure that this is returning. So it's returning a measure name and a table name. It's returning all of the formulas here in the measure expression, and then it's returning some additional data. Now, one of the things you might notice is that inside these brackets, right, the DAX uses a very structured language, which means that it's pretty easy to parse using a language like Python. And that's what we're going to utilize to, if we kind of go back to our original image, that's what we're going to utilize to actually start to build out these relationships here. Okay, so the next thing we need to do is we need to import pandas, which is a data analysis library. If you've worked with data at all in Python, you've for sure heard of pandas. You don't need to install the module similar to the Fabric module. It comes pre-installed in most Fabric tenants. So if I just go import pandas as PD, and then I'll go right here and I'll just go importing pandas, I can then go ahead and I can convert this data into a pandas data frame by going data frame equals, and I can go pd.data frame here, and I can feed it the Fabric structure that we just returned right here. And then I can go ahead and I can add a comment here. So I can go putting measures into data frame. And if we now run this one more time, you'll see it won't return anything. It'll just run all the way through because we now have our data flowing into pandas. All right, so what's next? Well, our goal is to create a directed graph. So we need a plugin that can actually create a directed graph. What I'm going to use is I'm going to use a module called NetworkX. And then I'm also going to import in a module that will essentially allow us to convert the NetworkX graphs into a graph for GraphViz. And GraphViz is a module that we don't have by default in our code. So I'm going to go ahead and I'm going to have to install that. And if you've never installed a module in a Microsoft Fabric notebook, you can do it in Python, just going pip install. And we'll go pygraphvi. And I misspelled that. And we'll run this just to make sure that that code is running through. So here it is running. And it's installing. You can see just like you'd install a normal package, and then you'll see it start to run through here. Going through. Okay. And it ran fine. So let's now go ahead and let's import those additional modules. So first I'm going to import NetworkX as NX, which is a package for creating and manipulating networks. Package for manipulating networks. Then we're going to go ahead and from that we're going to import the drawing package so we can convert the network to a graph. So I'm going to go from networkx.drawing.nx_a graph, import to a graph, and we'll title this converting network to graph. And then finally, we're going to want to display our graph in our Jupyter notebook. So let's also import something that allows us to display it. So let's go from, and then we'll go python dot display, and we'll go import image so we can display an image, and then we'll go display here, and we'll go allows us to display images in Jupyter notebooks. Okay, so I think we have a lot of our modules imported, and I think we need to go ahead and we need to import one more variable here. And that variable is going to be the measure, or create one more variable. And that variable is going to be the measure that we want the network graph to analyze. So I'm going to go measure, and I'm going to go equals in here, and I will go WIF adjusted sales. Okay, so there we are. All right, the next step for us is to create a base network graph, and then to build some code that can analyze all of the dependencies for every single measure, and then some code that can add all those dependencies into our network graph. So let's first try to write a method that can actually take a measure's name, and then it can return it as a new with all of its dependencies. Okay, so I'm going to go ahead and I'm going to add a new code block, and I'm going to start writing this measure. So I'm going to call this measure extract dependencies. So I'm going to go def extract dependencies, and that is going to take a measure's DAX expression. So I'm going to feed it a variable called expression. And then I am going to create a empty array, right? So an array is kind of a collection of values, and I'm going to create an empty array where I want to store the dependencies for that. So I'm going to go dependencies, and I'll go equals that to create a new array. And then I will say for measure in data frame. So remember, we have a data frame up here with all of our measures, and I'm going to want to take it for measure name, right? Name, and I need to add a one right here. If f, and I'll go in here, single quotes, and I will go and I'll go measure in expression. And remember, that's our DAX expression that we're passing in up here. Then dependencies dot append. So we're appending it to our array, the measure name, right? Nope, and I think I forgot a single quote up here, so I'll go and I'll fix that. Then finally, I want to return the array of dependencies. So what is this doing? Let's take a second and let's look at what this measure is and what it's actually producing. So it's taking in a DAX expression of a measure, and then it's essentially looping through all of the measures in our data frame, and it's appending the name of the measures that are dependent on that expression. Okay, and let's give this notebook a run through just to make sure that it is working. So let's go ahead and let's run this. Okay, and hopefully we don't hit any errors. So far we haven't. Okay, the next piece of this is we need to create our network graph. So I'm going to go ahead and I'm going to declare a blank network graph as nx.di. It needs to be a capital D graph. Here I'm going to go creating a directed graph because that's what I'm doing. Okay, and then I'm going to go in here, and this will be, we'll add a comment in here, and this will be a Python function to parse the DAX formulas and return measures within. Okay, because that's what we're doing there. And then we'll start writing some code over here to actually go ahead and to build our network. So we're going to say for index, comma, row in our data frames. Remember, our data frame contains all of our measures. It rows. Okay, and we'll go in here. Measure is equal to, and we'll say measure row measure name. We want to add a node to our graph for that measure. So we'll go g.add node, and we'll go in here, measure. Okay. And then we'll say our dependencies, which are going to be our edges, right? We're going to go dependencies equals, and we'll call this function up here to go and find all the dependencies. So we'll go dependencies, extract dependencies right here, row, and we'll feed it the measure expression, right? So the measure expression, or the DAX formula behind that. So we'll go measure expression. And then for each one of these dependencies, so for each dependency in dependencies, we will go g.addEdge, and we'll give it the measure name here, the measure dep, comma, measure. Okay. All right, so if we now take a look at what this code is doing, is it's looping through all the measures in our data frame, and it is creating a network graph. Okay, and let's go ahead and let's run this and just make sure that I didn't break anything and I don't have any obvious errors in my code. Okay, the next thing that I'm going to want to do is I'm going to want to just kind of put this in a function, or a method itself, just so my code stays clean. So I'm going to go in here. I'm going to title this build directed graph. All right. Okay, and I'll go here, and I'll go here, and then I'll need to indent this right here, and I'll move this comma up above this method. Okay, so I'm gonna go excuse me while I fix my spacing, and then I'm gonna add one more code block down here where I actually call the method. So I'll go build directed graph. I keep on saying method or function. I'm sorry, I'm slipping up over my words. But we now have some code, and we now have two functions here that are working. Okay, so the next piece of this, right now that we've actually created this measure, is we want to be able to feed our network graph a particular measure and have it only return the subnodes or the pieces that are relevant. So we're going to create one more final function, and that function is going to be def, we'll title it get dependencies, and we'll feed it a measure name. Okay, and this measure name is going to be what we're going to go through and we're going to kind of look at. And so if we think about with our code here, I'm going to go down and I'm going to call it dependencies, and I will feed this a measures name that I know is in this sample. So if you remember, I had this Power BI, right? Let's maybe go what's the image I keep on showing you guys as an example? All right, the name of the measure is WIF adjusted sales. So let's go over here and let's go here and let's go rename and let's grab that. Okay, and we'll feed it right here. Now this is throwing an error, and that needs to be in a string, right? But if you remember, we created a measure up here actually, so I actually should just pull it from up here. And let me throw that. So there we are. We now have something that's going to go through and it's going to loop through this. Okay, so remember we have this network graph up here. We now have this function right here, and we're going to want to return essentially a sub function of this directed graph. So the way we're going to do that is we're going to first gather all of the ancestors. So that's all of our upstream dependencies. So we're going to title this ancestors, and we'll go nx.ancestors, and we'll say of our graph, and then our measure name. Okay, so that's there, and our graph is a capital G, not a lowercase g. Python is case sensitive. Always remember that. And then we're going to want to get essentially our descendants, so all of our downstream dependencies. So we're going to go descendants, descendants. Sorry, I always struggle with spelling a little bit. We'll go nx.descendants, and we'll feed it that same graph and measure name. Okay. Then finally, we want to combine this. So we want all of our ancestors, our descendants, and the actual measure. So we'll title this our subgraph, right? Nodes, and we'll combine all three of these. So we'll go ancestors dot union, and we'll union our descendants. Okay, and then we'll finally union our measure name that we are fed. So we'll go union, and then in here we'll do some curly brackets, and we'll go measure name. Okay, so we now have a subgraph that contains just our measure and then all of its upstream dependencies and then all of its downstream dependencies. So this is looking pretty good. The next thing we need to do is we need to actually create a new network graph. All right, that's kind of our subgraph. So we'll go subgraph and we'll set it equal to g dot subgraph here. And we'll say we want it of all of our subgraph nodes. Okay, so there we go. Finally, let's go ahead and let's run this. So if we run this, you'll see it'll start to finally go through and it will hopefully run. Okay, so it's running. So that we now have a subgraph, right? And we should be able to actually like convert this to a graph and then output it to the visual now. So I'm going to go a dot a equals, and we'll go to a graph, and we'll feed it our subgraph here. And then we'll output that to the output of our Jupyter notebook by going, we'll define an output path here of equals f, and we'll just go backslash for now. And then we'll actually make that graph of a dot draw. And we'll say, well, we want you to draw to the output path. And then we'll say we want it in a PNG. So we'll go format equals PNG. And then finally, we'll display it to the Jupyter notebook by going display up here. And we'll say image, and we'll go file name. And we'll go, our file name will be our output path. Okay, so let's run this and let's just see what happens. And hopefully I don't have any errors here. But what we should see is we should see our image of our measure name popping out. And we're getting an error. And let's just figure out why. Graph has no layout information. Okay, so that is because I forgot a line of code here. I need to actually define a layout. So I need to go a.layout right here, and I need to go prog equals dot. Okay, so there we go. So I just defined a layout, and let's just try this one more time. Okay, let's give it a second. Up, and we're still getting an error. So let's go error backslash is a directory. Okay, that's because I need to give it a file path. So I'll go right here and I'll go, I'll feed it this measure name, right? So I want it to output the measure name. So that way it outputs the file. This will essentially generate a file name with the file name that I inputted. And then I'll go underscore dependencies.png. And we'll just try this one more time, and we'll let it go. And hopefully this will be the last of the errors. And, nope, it was not. We'll get one more. Our permission was denied. Okay, so that is because when we're dealing with local files and notebooks, you need to kind of understand where they exist or where we're actually writing in Microsoft Fabric. So there isn't really, at least to my knowledge, much of a flat file storage when you're dealing with a Microsoft Fabric notebook. Instead puts it in a blob. So what you have to do is you have to add a Lakehouse, and remember Lakehouse is our files, and then you can save it in that location in the Lakehouse. So I'm going to go ahead and I'm going to add a Lakehouse by clicking that Lakehouse button. I'm going to click add, I'm going to add an existing lake house, and my existing lake house is going to be this test lake house right here. And I'm going to stop, and I'm going to add the lake house really quick. And then once this is here, as you can see, I can now see the files section of the lake house. So I can now go back into my code, and I can write to that files area. So I can go lakehouse /default /files /measure name. And so now I should be actually accessing into this lakehouse location and saving the file there. So let's go ahead and let's give this one more time, and hopefully that's it for the errors. That's all we're dealing with. So let's let it run. And knowing my luck, I'll probably get one more error here, but maybe not. Okay, it's running. And if you look at that, look, we got a graph. Now, this graph is pretty simple. And if you notice, it's a set size, right? And you can't tell what the original measure was. So we need to kind of figure that out. So let's go ahead and let's start writing through some formatting options. Okay, so the first thing I'm going to want to do is I'm going to want to format the name or the node that I measured so that it's different than the other nodes. So the way I'm going to do that is I'm going to define essentially a selected node in my graph. So I'm going to go selected node. I'm going to say equals a.getNode, and I'll say get node of the measure name I'm feeding in. So I'll say get node measure name, and then I will start setting some attributes. So I'll go selected node, and I'll say equal or dot attribute attr, and we'll say color equals yellow, or let's go color equals red. Okay. And let's go ahead, and I need to put this in some single quotes here. So and let's go ahead and let's give this one more run. And then let's call this one more time. And if you notice now, look, this outline is now red. Okay, so let's go ahead and let's fix, and that looks good, but it's still not quite clear enough. So we're gonna add a few more attributes here. So we're gonna go selected node dot attribute, and we'll say style here, and we'll want the style to be filled, right? And so we'll go style equals filled, and then we'll go selected node, and we'll go dot attribute one more time, and we'll go fill equals fill color equals yellow. Okay, and now when we run this, if we look, we should now be getting our fill. Now, the graph that this is outputting is readable here, but we need to think through a few other problems. So what if the file that we're outputting here is really big, right? Or like the size, the number of like upstream dependencies is a ton, and the number of downstream dependencies is a ton, and so it's really big and we won't be able to read it. And then what if the opposite is true? What if it's really small and we can't read it? That would be a problem. So what we're going to do is we're going to set a few more visual settings of our graph here, just so we can start to build this. So the first thing that I am going to go ahead and I'm going to do is I'm going to start setting some visual settings. The first visual setting is going to be an attribute of the graph, and the second group of visual settings that I'm going to be changing, they are going to be essentially attributes of the nodes. So the first thing, and I'm going to start doing some comments here. I'm going to type out what I'm going to actually do. The first thing I'm going to do is I'm going to set the actual size of graph. Okay, and I'm going to do this in inches, and I'm going to use a exclamation mark here to ensure the aspect ratio is maintained. The aspect ratio of the graph is maintained. Okay. The next thing that I'm going to do is I'm going to set the DPI of the graph. Okay. And I'm going to do this to make sure that the graph is in a high resolution. Okay, finally, I'm going to set two more things, which is going to be the rank step and then the node step. And the rank step is going to be the vertical space between the nodes in the graph. And then the node step is going to be the horizontal space. So we'll set rank step, which is going to be the vertical space. Okay, and then we're going to set node step, which is going to be the horizontal space. Okay, so now let's go ahead and let's actually write the code to do this. All right, so we'll go a dot graph attribute dot update, and we'll go in here and we'll go size equals, and we'll go comma, then we'll go DPI equals. Okay, then we'll go rank step equals, and then we'll go in here and we'll go node step equals. Okay, and these all need to be strings in here. So I'm going to go ahead and I'm going to set these right here. Okay, and my size, I'm going to go ahead and I'm going to make this 30. Oh, and I just tried to use my numpad and just threw an error. I'm going to make this be 30, comma 30, so it's a square. Right, and then I'll go exclamation mark. My DPI will be 300. My rank step will be in here. You know, maybe my rank step will just be 1. And then my node step will be 0.5. Okay, so let's go ahead and let's run this. And I'm fully expecting this to be a really ugly graph, just so you guys are aware. So remember, here's the pretty graph that we had before, and let's run this. Let's take a look at what these settings that we just did. Oh, it's a lot bigger, that's for sure. It's still readable though, which is good. But you know, maybe let's do this dynamically. So what we need to do in order to set this dynamically, right? So like if it's a really small one versus a really large one, is we need to update the values that we're giving each one of these dynamic. So let's go ahead and let's fetch our number of nodes. So we'll go number of nodes and we'll go equals the length of our subgraph nodes, right? So that's our total number of nodes we have in this subgraph. Then we'll return the total number of edges. So we'll go num edges. And we'll say equals length of subgraph edges. Okay. And then finally, we'll do one more here where we'll get the total number, the total size. So we'll dynamically set a size value. So we'll go size equals right here, and we'll go number of nodes times 3, comma, number of edges times 2. Okay, and you can start to see this. And then we'll calculate out our total rank step, right? So like how much we need. So we'll go our rank step is equal to the max right here of 1, and then our number of nodes divided by 5. Okay, and then we'll go 1 right here. And I said node, I said num node there. Okay, and then we'll go right here and we'll go our node step is going to be equal to our max times 0.05. And these are just dummy values. You can go ahead and you can change this until you get like a graph you want. But the idea here, right, is that the image is going to be dynamic. So let's go ahead and let's use that, right? So in here, right, these are strings and this is returning a number. So I'm going to have to convert it to a string. So I'm going to go str in here and I'm going to put in my rank step. And then I'm going to go back over here, do the same thing over here. So I'll go str in here as our node step. And then our DPI is like it's fine static, right? Like I'm fine with 300 resolution, but what we need to do is we need to reference our size variable in here. So we're going to go we're going to go comma, and then in here, and then finally we can reference this with our size 0 and our size 1 here. Okay, so let's go ahead and let's run this through and make sure I didn't break anything with that dynamic sizing. So I'm going to go up here to this block right here and I'm going to run it. And then I'm going to run it one more time down here. And as you notice, look, our sizing is looking pretty good. And let's just test out our dynamic sizing here by going ahead and actually like kind of getting this. Let's feed it another measure. So I'm going to feed it returns instead. So I'm going to go back up here and I'm going to copy returns. And let's go up here. And let's title this as returns. And we'll rerun this cell right here. And then we'll rerun this cell right here. And then we'll rerun this cell right here. And if you look, our dynamic stuff really like built this out. And then look, we can see all of our dependencies coming through, which is really cool, right? So look, this is pretty neat. Now we're getting a really nicely formatted thing, but one of the things I also want to update with our formatting here is I want to update our node attributes. So let's go through and let's kind of talk through the node attributes that we're going to want to update. Okay, so the first thing I'm going to want to update is I'm going to want to update margin. So this is the margin around each node, kind of like padding in Power BI. Okay, the second is going to be the shape, right? I like the circles, but I want boxes. So I'm going to set this to boxes. So that's the shape of the nodes. Okay, the next thing I'm going to adjust is the font size of the labels, right? So font size of labels. Then I'm going to set the width and the height. Okay, and these could be dynamic too, but for now, I'm not going to go and I'm going to just not set these. But, and just by the way, this is the width of the node box and then the height of the node box. Okay, and so I will update these by finally going right here. I'll go a.node attribute and I'll go .update and I'll go in here and I'll go margin equals and just give it a string there. And then I'll go shape equals, give it a string there, and font size equals, give it a string there, and then finally I'll go width equals, and height equals. Okay, so let's go ahead and let's just set some values in here. So my margin, I will make it be 0.8, and I'll make my shape be a box because I want a box, and then I'll make my font size be a 30 and 30 pixels, and my width be 2 inches and my height be 1 inch. And let's go ahead and let's rerun this one more time. And let's rerun this right here. And give it a second. And hopefully we should get nodes here. Right, and there we go. Look, see, there we go. We're getting everything in boxes and it's nicely organized. And you can see these formatting settings. All right, now, finally, one of the last things we probably want to talk about is how do we access this image, right? I don't know if you noticed, but when I keep on trying to drag this and like save it and like right click it, right? Like I can save the image here, right? But it's downloading and it keeps on adding in this text that says, please add to Lakehouse. Well, remember, we're writing to the actual Lakehouse. So if I want this file, I can just go into the Lakehouse and I can get the file. So let's go ahead and let's do that. So I'm going to copy this right here and copy this right here. And if we go on in, you guys are going to get, and I'm going to go into my developer in here and I go into my test Lakehouse right here. and then I go into files, right? Here's all of these images that I've been updating. And you can see I've been playing with this for a little bit. I'm going to be honest with you guys. I'm not that great of a coder. Like, I've been playing with this a fair amount before this video, but you can then click into here and it'll load an image. And right here's that image we were just outputting. And I can go right here and I can go file, save as, and I can save it as my returns. Remember, it's a ping return PNG. And if I go right here and open that file, here's that documentation, and here is the measure. Isn't that cool? So that's Microsoft Fabric, and that's how you can use Python to build and track measures. Thank you for watching. If you enjoyed the video, please consider subscribing and liking.